When you think of OpenAI, your mind probably jumps to Sam Altman, or maybe to the models themselves, like ChatGPT. But today, we're going to dive into the mind of its co-founder, and really the architect of its technology, Greg Brockman. He's not just the CTO. He's kind of the perfect example of a new kind of innovator for this AI age, the builder.
Okay, so let's just park on this for a second. Because this one little phrase, we just need to build, well, it's not just some corporate mantra. It's the key that unlocks his entire philosophy. It's what explains his whole journey, from being a college dropout to, building the actual infrastructure for what might be the most transformative technology humanity's ever seen.
So, where does this relentless drive to build really come from? Well, to get that, we have to go back to a choice he made between the super abstract world of mathematics and the very, very real world of code. Originally, Brockman wanted to be a mathematician, solving these incredibly complex problems that maybe, just maybe, someone would find a use for in 100 years. But then, he taught himself to code to build a website. And the second he built the simple little table sorting widget and it worked, boom, everything changed. With math, you write a proof and maybe 3 people on the planet will ever read it. But with programming, the thing that was just an idea in your head is suddenly real. It's in the world, and anyone can use it, even if they have no idea how it works. That was the magic he knew he had to chase.
And this mindset? It got forged in the fire of an early-stage startup. At Stripe, they needed to do this critical integration with Wells Fargo, and the bank quoted them 9 months. 9 months? For a fast-moving startup, that's basically a death sentence. So what did they do? They treated it like a college problem set. They locked themselves in a room, and in this frantic 24-hour sprint, just hammered out the entire integration. They were literally debugging it live on the phone with the certifying agent, who probably thought he wouldn't hear from them for another week.
So here's the big takeaway from that story. Speed isn't about just being reckless. It's about thinking from first principles. It's about looking at some established process and asking, wait a minute, which of these rules are just bureaucracy? Which of these constraints were designed for someone else's problem, not mine? And in a world that's being completely remade by AI, that question is more important than ever.
So when you have a mindset that's obsessed with making ideas real and breaking constraints, it was almost inevitable, really, that he would be drawn to the biggest challenge of them all: artificial general intelligence.
His jump into AI wasn't some random leap of faith. It was methodical. First, he just started noticing all these posts about deep learning popping up everywhere. Then, he spotted the real signal. All of his smartest friends, the people he respected most, were all quietly moving into AI. So he acted. He left Stripe, bought a couple of Titan X GPUs, and physically built his own machine from scratch, just so he could teach himself the fundamentals. He had to build it to understand it.
But the real lightning bolt moment, the true vision, came from reading Alan Turing's original paper from 1950. It wasn't about the Turing test, not really. It was this one incredible idea. Instead of trying to program all the rules into a machine, what if you could build a child machine? One that learns on its own, just like a human child. A machine that could figure out how to solve problems that you, the programmer, don't even know how to solve. That was the revolution he knew he had to be a part of. For years, that whole vision just felt so far away. AI was stuck in these little silos. You had computer vision over here, natural language over there. But then, deep learning happened. It started with AlexNet in 2012, this general learning system that just obliterated 40 years of specialized computer vision research. And then it started doing the same thing in every other field, just tearing down the walls between all these different disciplines. This was it. This was Turing's child machine taking its very first step.
Okay, so having the vision is one thing. Actually building it is something else entirely. And at OpenAI, that meant figuring out how to create a new kind of partnership between two very different worlds: engineering and research.
And this is where you run into some serious friction. See, in normal software, engineers are taught to respect the interface. As long as the inputs and outputs work, what happens behind that curtain is their business. But for an AI researcher, it's totally different. A tiny subtle bug somewhere deep in the system doesn't cause a crash. It just silently makes the model a little bit worse, so the researchers feel like they have to be responsible for everything. And that clash in mindset, it could have just ground all progress to a halt.
So what was the solution? Brockman calls it technical humility. Basically, it means that when brilliant engineers come into this world, they have to leave their old instincts at the door. You have to come in, you have to listen, really listen, and just assume that you're missing something until you truly get the why behind what the researchers are doing. Only then can you actually start applying your skills to build the right systems.
At the end of the day, it has to be a real partnership, right? You can have the most brilliant research idea in the world, but it's totally useless if you can't engineer it at scale. And you can have the most powerful engineering system ever built, but it's also useless without a groundbreaking idea to run on it. You're dead in the water without the idea, and the idea never sees the light of day without the engineering. The synthesis, this combination, that's the real engine of OpenAI.
So, what does the output of that engine actually look like? Well, it's changing the very nature of building itself. It's creating this new generation of tools that are empowering developers in ways we're only just starting to wrap our heads around.
I want you to think back to the end of 2022. OpenAI drops what they called a low-key research preview. They really weren't expecting much, but the world saw the magic of ChatGPT, and in just 5 days, they hit this number, 1 million users. At the time, that felt absolutely insane.
Now, let's fast forward just over a year to the launch of GPT-4o. In that same 5-day window, the user count wasn't just a bit higher, it was an estimated 100 million. That's not just growth, that's a totally different universe of adoption. It just goes to show how fast these AI companions are becoming a part of our daily lives. And all of this is leading to totally new ways of creating things, like what's being called vibe coding. We saw this in that wild GPT-4o demo. It's not about just auto-completing a line of code anymore. It's about describing a feeling, an idea of a vibe, and having the AI translate that directly into a working app. Brockman calls it an empowerment mechanism, and it's really a preview of what's coming next for all of us.
But look, flashy demos are one thing. The real revolution, and honestly the next huge challenge for builders, is going to be tackling the really hard, unfun work of modernizing the world's existing software. We're talking about transforming ancient COBOL systems or migrating these massive, tangled messes of code. That's where the builder's mindset sees the next giant opportunity.
Which brings us to the future. With these incredibly powerful new tools in our hands, what are the next great challenges that builders need to solve?
This question from NVIDIA's Jensen Huang really gets to the core of the next massive infrastructure problem. How on earth do you build data centers that can handle two completely opposite needs at the same time? On one side, you need this enormous raw power for long, deep research projects. And on the other, you need instant, low-latency responses for interactive AI companions like ChatGPT. It's a mind-bending engineering challenge.
And according to Brockman, we're actually entering a whole new era. For a little while, it felt like progress was all about just throwing more compute and more data at the existing models, like the transformer. But now, we've pushed that so far that the bottleneck is actually shifting. We are back in a world where the biggest breakthroughs are going to come from fundamental, basic research and brand new algorithms.
And this gets to the ultimate goal. So often, the conversation about AI gets stuck on replacement, or what jobs are going to disappear. But Brockman argues that's completely missing the point. The goal isn't a zero-sum game. The point is to create a positive-sum world, a world with 10 times more activity, 10 times more economic output, and 10 times more benefit for everyone. It's about massive expansion, not replacement.
The AI-powered economy is coming. That's not a question anymore. It's a fact. The tools are getting more powerful literally every single day, and the barrier to start building is lower than it has ever been. Greg Brockman's journey shows us that progress comes from the people who see a problem, who break the old constraints, and who simply decide to build. So the final question really is for you. What will you build?